Hello! In this video we are going to talk about the limits when x approaches plus infinity or minus infinity. This is a very special type of limits and we need to find a rule to obtain these values. Which are the objectives of this video? The objectives are to understand the idea of limits and horizontal asymptotes because they will appear during the process. We will learn and apply methods like L'Hopital rule, that is a very important tool that you can use when calculating limits, special types of limits, not always, be careful. And we will also explore the asymptotic behavior of functions when x approaches to infinity, plus infinity or minus infinity. Okay, requirements as usual are very low. There is not so much to know in order to understand what we are going to do in these videos. Some basic knowledge of calculus, some familiarity with polynomial functions and their properties, and also a small understanding of algebraic manipulation techniques. I hope you can follow the video without any problems. Okay, let's review the limit a little bit, the idea, and we will just move to some techniques that we will apply here. We say that the limit of a function when x approaches plus infinity is equal to one value L if the function gets closer and closer to this value L as x becomes larger and larger and larger, always positive, okay? So x is, you take values x each time greater and greater and greater and greater, and then we are studying what is happening to the function. Is the function getting close to a value? Then we will say this value is the limit. The same happens with the limit when x approaches negative infinity. What happens in these cases? You have the function, and we will say that this limit is L if the function gets closer and closer and closer and closer to this value when x moves to minus infinity. It's getting greater and greater, but in the negative sense, I mean, minus 100, minus 1 million, etc. Okay, if this happens, then we will say that the function has an horizontal asymptote at y equals L. We will see in no time a graph in which we can see what is this horizontal asymptote. Okay, example, piece of cake. We are not going to apply any rule, just we are going to try to find what is the limit of this function you see on the screen when x approaches plus infinity. Okay? And we are going to do it in a way that you don't need to do it next time. The idea of this video is to provide some tools that you can use next time you are dealing with a limit when x approaches infinity or minus infinity. Okay. If we apply the substitution rule, if we just replace x by infinity, we have a polynomial on top and polynomial below. You can see the two polynomials has the same degree. And if we replace x by infinity, infinity squared is infinity, multiplied by 3 is also infinity. We subtract infinity. Oh, be careful. Be careful. It can be something different. Okay. But let's suppose this is bigger, so minus infinity is also infinity. So the same happens in the denominator. Be careful with these techniques. But okay, the idea is that we are going to obtain infinity over infinity. This is an indetermination. This is something we don't know how to solve. Okay, but let's see how can we solve this indetermination. When we are dealing with this kind of limits, the key point or the key idea behind this is to divide by the maximum power of x power to the maximum exponent, I mean. For example, in this case, we have x squared, x, and x to the power 0. The same happens on the denominator, x squared. So we are going to divide everything by x squared, the maximum power function, or the power function that has the maximum exponent in this case. So if we divide numerator and denominator by x squared, what you obtain is 3. The first one is obvious. 3x squared divided by x squared is just 3. X divided by x squared is just 1 over x after simplification. And 2 divided by x squared is 2 divided by x squared. Nothing to simplify in this case. On the denominator, it happens the same. We divide by x squared all the terms. So we have 5 minus 4 times x after simplification plus 1 over x squared. Now, if we substitute x by infinity, what do we have? 1 over infinity tends to 0. 2 over infinity tends to 0. 4 over infinity tends to 0, and 1 over infinity squared tends to 0. So this part of the fraction disappears. The only thing left remaining is 3 over 5. So, okay, perfect. This limit exists, and the value, the final, or the value to, for which this function tends to is 3 over 5, a constant. Then we say that 3 over 5, y equals 3 over 5 is a horizontal asymptote. Okay, this is a very nice technique to resolve an indetermination infinity over infinity. Okay, let's plot the function. As you can see, this is y equal, sorry, let me go back 1 second, 3 over 5. I wasn't sure it was 5 over 3 or 3 over 5. Okay, so this is 3 over 5, this is the line, this is the horizontal asymptote, and the function approaches to, when we tend to plus infinity or minus infinity, the function approaches this horizontal asymptote. Okay, so this is the situation we had before. Okay, let's continue. Can we simplify this process for the next time? We have a rule, the rule of the degrees, or the degree rule. In this case, when you have a quotient fraction of two polynomials, then this limit when x tends to infinity is going to be 0 if the degree of the denominator is greater than the degree of the polynomial, of the numerator, sorry. Okay? Then it will be L, a number, when the degree of the numerator and denominator equals. And it will be infinity if the degree of the numerator is greater than the degree of the denominator. So there's only 3 situations. You only need to check the degree of the numerator and denominator. Now, let's review it very fast. If the one on top, the numerator, the degree of the numerator is greater, infinity. If the degree of the denominator is greater, 0. If both are equal, then the limit is the coefficients multiplying the power function with the maximum exponent. Okay, we are going to see some examples to review that thing. Okay, take a look to this limit. Limit when x tends to infinity, and on top we have a polynomial of degree 1, below a polynomial of degree 3. The degree of the denominator is bigger, therefore this limit equal to 0 directly. Okay? Piece of cake. Then what happened, for example, in this case? We have a limit when x tends to infinity. On top we have a polynomial degree 2, below another polynomial of degree 2. What happened in this case? Same degree, the limit is 3 over 6. The numbers, the coefficients multiplying x squared on top and below. So, by the way, 3 over 6 equals 1/2. We can simplify that. So, piece of cake again. Finally, what happens with a limit of when x approaches infinity of a quotient in which the numerator, the degree of the numerator is 4 and the degree of the denominator is 2, or the one on top wins, then the limit is infinity. Okay, so as you can see, you don't need to make any calculations. You only need to remember the rule, and then you can solve easily any limit of this type. So what have we seen in this slide? We just introduced the idea of horizontal asymptotes. We have seen, we didn't apply L'Hopital rule, but it's a technique in which you can calculate the derivative of numerator and denominator, and we just make it in a different way, not using still derivatives. But of course, you can use L'Hopital anytime you need, only for indeterminations infinity over infinity and 0 over 0. Okay? And finally, we have seen some graphs and limits in which we have applied this rule. I hope this is helpful for you, and thank you for your attention, guys.